What's up, fellas and ladies, if there's any out there? Back in the shop with something different. This is a set of plans from Larry B off of RC Scale Builder for a Vought aircraft V-173 flying pancake. I've had these for probably a year and a half now, and he graciously enough had copies of his plans sent to me, and for just the price of copying. And what I did is I took his plans and I've kind of expanded on them. His plans basically gave you the cord line, and then it gave you the outside, basically the outside shape of the airfoil for the airplane. I believe he said these are airfoils, outlines, everything are directly from the Vought factory drawings, so it's as accurate as you can get. Like I said, since his was just the cord line and the outside line, there's a lot of internal stuff that was kind of left out that he just figured out as he went through it and didn't really build. He basically made a set of drawings for him to build off of. They worked out great. I sat there and after talking to him, I kind of decided that I was going to expand on his plans a little bit and make them a little more newbie friendly for those who have never actually built up a set of stick built ribs before. So these things are built literally like you would see a full scale home built airplane or most home built airplanes that are wooden wings built like. A couple things I did to make them make it a little easier. All their wing ribs are 1/4 inch thick balsa or 1/4 inch sheet balsa. Come down here and I'll zoom in on a couple of the ribs. The ones you're looking at right here, this is a center wing rib. Then the next one, I think there's 12 ribs. Yeah, 12 ribs total. 13 if you count 0 as number 1. So there's 13 ribs per wing and half. You only have to do one number 0 rib. So there's 25 ribs in the wing. Spans 46 inches, and the cord down here at the center, this number 0 rib, is 45 inches. It's not a big airplane, but it's a big airplane in different ways. I mean, this center rib here is, let me get my ruler out. It is about 7 1/4 inches thick at its thickest, at its widest point, which is just a little bit behind the spar. So basically what I did, all the nose ribs here, all the nose of the rib is 1/4 inch sheet balsa, and then down at the trailing edge you can see this is also 1/4 inch sheet balsa, and everything in between is 1/4 inch square sticks. And you can see there's lots of verticals, lots of diagonals. All of this is just to keep this thing nice and strong, so it doesn't want to warp or twist or anything. This is all open area, and this is open area. And the reason why all this is open, save weight. 2 is it gives you lots of options for where to put your landing gear, batteries, because this airplane really should be electric. I'll show you one later on. You could do gas or low or whatever, but electric's the way to go with this airplane. The top rib here, you got this nice big square spot for battery compartment. It goes out 4 or 5 ribs before the ribs start looking like this again. So I mean, there's plenty of room for, God, you could put 20,000 milliamps of batteries per electric motor on each side. Have plenty of room. Main spars here, it's 1/2 inch thick. And what I did with this is I took a 1/2 inch, I took the dimensions from the center line to here, and basically I have a spar that comes out and it curves. But as it curves, as it goes out to the tip, it steps down. And as it steps down, the ribs just literally slide right up against the steps, Next one goes out against the steps. Next one, next one, next one, next one, all the way until you get all the ribs out. And the only one that doesn't have a step is the center rib. And then a couple of the other ones, the step's just so small. I just made that portion of it actually just kind of taper at a not quite a straight line taper, but a curved taper. So they just slide on as far as you can get them. But those spars are 1/4 inch sheet boss in the middle, and then there's 1/16 inch vertical shear webbing, and then it actually slides here in these slots, and these slots are all in the same position of wing ribs. So the curve of the leading edge and everything goes the same with the trailing edge. So what you would literally do is you would take this spar, you would build it flat on your table, put some 1/16 inch ply and some 1/4 inch hardwood in between the plies, shear webbing where like the landing gear wires and stuff would attach to, and then 1/16 inch shear webbing boss everywhere up, so you get a nice thick 1/2 inch spar. Slide it through, elevate the spar off the table, make sure your incidences are set on all your ribs for 0, and then have little vertical standoffs at the trailing edge to elevate the trailing edge so you keep your incidences all set. So that's how you would go about setting up or actually building the ribs, or my thoughts on how you would build the ribs and then get them set up to where the wing's straight, because it's just the wings, so you want to get as close as possible. This sheet with just wing ribs is 3 foot by 12 foot. It's a lot of a whole lot of wing ribs. Here, what I have is, this is 1/2 of the, I guess, the plan view of the airplane. And you can see there's a whole lot of ribs in this thing, and they're not spaced very far apart. I think it's about 2 inches. So from center line to this number 0 rib out here is about 23 inches or so. The reason why I say electric is the way to go is right up here. Let me zoom in, is that little thing right there. Basically, Larry took a cardboard shipping tube and just had his here, and I think he put a plywood firewall, and then he had an outrunner and a speed control, and I think he had 4S5000 setups or whatever for powering this thing. So that's what he did. Those of you on RC Scale Builder know that the reason why I hadn't really started work on this very much is because I want to use a scale weighted or scale diameter prop, which is like 36 inches in diameter. And because the prop's so huge in diameter, you want to spin it at like 1700 RPM, which is scale RPM as well. You got to run like a 20 some odd inch pitch prop, and props, getting them are not the problem. I can actually have them custom cut in Germany for about 150 bucks a piece, 200 bucks a piece. The problem is finding something that can spin those things at such a slow RPM and be efficient. And that's why I haven't done it. But the easy way to do it is just a pair of outrunners out here in this tube. You can use this shipping tube that you can fiberglass. You can make a composite tube. They've probably got fiberglass or carbon fiber tubes that are big enough. It's 3 1/4 inch diameter on the outside. And there's tons of options of what you could do here. But it's perfect for just putting an outrunner and a speed control and then running an extension for your batteries. So that's why it should be electric. Here you can see where that spar, well, let me move the video camera for you guys. Here you can see where the spar runs through. It's pretty far back. Another thing with that spar I have, I've got it set up to where this 3 1/4 inch diameter comes all the way back, and then it's got a little kind of a square looking rounded edge thing to where you can take your tube here, cut like the top and the bottom third of it off, and then it interlocks into the spar. That way everything here stays nice and interlocked as well. Like I said, when I was doing the plans for this stuff, that spar is drawn up in SolidWorks, so it's symmetric both side to side and top to bottom, and it interlocks together, so it's really well done. Well, I think it's really well done, at least in CAD, but actually having to see if it interlocks and works with the actual physical parts is a whole other thing. So that's one thing I did. Out here is a wingtip. I think Larry said he used some blue foam or something from Lowe's to shape it, because this has got like a huge rounded thing. You can use balsa wood and then hollow it out, whatever. The trailing edge is basically just sheet balsa. And you can see what I did with the outline here is I basically just did about 1 inch wide, all the way back, all the way along, all the way up until to the back side of it. And then I separated it into 3 parts. I believe we got one part here, and there's another separation right about here. And I could have sworn there was another one, but maybe I just did it in 2 separations. So that will go in slots that are cut into the back of those trailing edge sheet balsa pieces. And that basically gets you the main portion of the wing done. Surprising. It's like, oh, you can build this thing in a day. Well, in reality, probably not. All right. Horizontal stabs, or the elevators as I call them. You can call them L-bonds, whatever, I don't care. It's your own choice. See, here's the outline of them. Larry's were foam core that he cut himself. I'm not sure what airfoil he used. It's probably something symmetrical. So that's what I did. I went into Fuselage. I've got all the ribs for this drawn up for a built-up setup. The only thing in the ribs I don't have is the 3/4 inch holes for the pivot rod. The only reason I'm using 3/4 inch, or I suggest a 3/4 inch aluminum tube, it's just because the things are, there's nothing that really else structure-wise for these things. I mean, if you got some ribs and 1/4 inch square balsa spars or whatever, this is sheeting, that's it. And these things are pretty thick. I mean, you're talking about, they're about 1.5 inches thick here at the 1.5 to 2 inches thick here at the trailing edge, or at the root, and then I think the tip's like 1 inch or so, or 3/4 of an inch. So it tapers down, and this big 3/4 inch aluminum tube, I think it's the same size Larry said he used. So it seemed to work out pretty well, and it goes way far into the wing. I think it's about 9 inches or so. Oh, stupid video camera. I think it's about 9 inches into the wing that it goes into. That's another thing, is on the wing ribs where this tube goes through, I've put pieces of 3/4 or 1/4 inch thick balsa supports in there for the tube to go in. So again, this is all drawn up in Fuselage for built up. Foam core would be a lot easier. If any of you guys want to cut foam cores, I'd be interested in a foam core setup, especially if you could do the wing tube as well. It might be something where maybe we should talk to one of the foam core guys, and I can send him the sheet here, or just this portion of the sheet, and he could cut them out for us. And if we get like 5 sets of them or whatever, or 5 pairs, he'll cut us a good deal. Control surface wise, you got these, throttle and rudder. That's it. So you really only need, I mean, you could get away with 3 servos in this air. It's 3 or 4 servos in the entire airplane. This pivot, also this tube, is also the pivot for making your elevators and all work. So you'd have to drill a hole in here, put a standoff with a bolt, and then a servo out here or back here or something to make it work. So span wise, including those, you're looking at 68 inches, right on the money. So pretty nifty. Another thing I started drawing up was the vertical fins. You can kind of see the drawings there. I haven't figured out any, I don't think I've done wing ribs for these yet. I think all I was going to do is I was just going to freehand it. But basically, it's built up by using kind of like Dave Anderson, whatever, I forget his name, but basically it's a 3/32 inch balsa core, and then you put in your leading edge, your trailing edge, some pieces of I think it's 1/8 inch balsa for your ribs, sand it to shape, sheet everything with 1/16 inch, or sheet the fin with 1/16 inch. The rudder is not sheeted, it's fabric cover on the real one. And then the leading edge and the trailing edge actually extend out a little bit to go into the wing surface here. Vertical fin leading edge goes here, trailing edge goes here. You see it's not lined up with any ribs or anything, which kind of sucks, but whatever. All you'd have to do is just basically run a piece of 1/4 inch balsas from each of the ribs here, big enough for the 1/4 by 1/4 balsa trailing edge to slip down into. And then once that's there, you got it nice and straight. Do the same thing on the front to support that, and then fill in the gaps on either side with some scrap balsa to lock it in place really well. And that would tie all these, at least tie these two ribs together to where they're not going to try and twist on each other. Which brings me to another thing about the wing, is since the only true structure to it is the main spar and then the trailing edge sheet, you're gonna have to cross brace all these ribs to each other so they're not going to sit there and try and twist on you. So basically, starting at the tip all the way out here to the root, you have to run like railroad trellises. You're gonna have to do up on one rib to the next, and from that top rib down to the next one. You have to do that the whole way, and then you have to do it again a little further away or right next to each other, going the opposite direction. So you get basically an X between the ribs to sit there and help them, so they're not trying to fall apart and twist away from each other. That's why this thing uses so much 1/4 inch balsa. When I get done with this video, I'm gonna pull out my tape measure. I'm gonna start measuring the ribs to see exactly how much 1/4 inch balsa is gonna be needed. Like I said, about 200 linear feet for just the sticks on the wing ribs, what I guesstimated. I'm pretty sure it's gonna be at least that much. So that's the top view of this thing. For you, the next one, yeah, the next sheet is just basically the other side of this, which is basically what I started with. And you can see it's just lines of everything. There's not a whole lot of do this, do that. I tried to make it a little easier on this one by saying do this, do that. Excuse me. Alright, the next sheet basically shows the airplane, the side view, as it sits on the ground. And it's got a pretty pretty cool stance. When I said it's got a lot of clear glass, I basically meant it's got a lot of clear glass. Here you can see the canopy. Nice side view of it. Somebody would have to get somebody to carve this thing. I think Larry said he might still have the plug. Maybe we can talk him into giving us a plug or letting us borrow it or something. But anyway, there's the canopy. See here along the leading edge on the bottom of it was clear glass as well, pretty far back, because you can actually look through your feet and see the ground. And then the super long landing gear struts. I mean, these things they're long, guys. See, from the bottom surface of the wing to the axle location is about 12 inches, and they were functional oleos on the real one. So I'd highly recommend putting oleos on these. And then you've got this trailing edge support as well, for this drag support, which is 13 inches. And then the toe wheel all the way down here. But that's the 173 plans. It's a daunting task, but I tell you what, this thing is one cool looking airplane. I've been wanting to build it for a while. I probably should have built this before I did the Horton, but the Horton was just too cool to pass up. Kind of regret selling it at times, but at the same time, you gotta do what you gotta do. That brought in money for this beast of an F-14. All right, so kind of do a materials list. Typically what I do is I just take the widest wing rib. In this case, it'll be number 1, and I use it for the next 5 ribs. I do 6 ribs for this one since there's 12, 13 ribs, and then rib 7 I use for the next one. That way you always end up with a lot of extra material. That's basically one 36-inch stick, two 36-inch sticks. .36, and then you're gonna need let's see, 7, 8, 16, 7, 14, 21, 28, 34, 40, 44, 48, 48, 53, 59, 68, 76, 76, 84, 94, 94 inches, and 72 inches. So there's 166 inches of balsa, quarter-inch thick balsa in this one rib. That's 10 feet right there. So you're talking about 60 feet and 6 ribs. So there's that one. Let's go to rib 7, which is over here, which is kind of halfway obscured by the F-14. 28, 56, 6, 12, 68, 7, 14, 78, 82, 88, 95, 100, 107, 111, 117, 120 inches on that one. So whole lot of wood is going to be needed. 10, 12, 16, 17, 4. So there's basically 38 feet of balsa, quarter by quarter balsa for the first 7 ribs, and long division, long multiplication, you always forget how to do it, don't you? It's 120. And 70 feet for the other one, so you're talking about 110 feet, a quarter by quarter. That's just for the sticks for the ribs. Might as well say another, that's a 20 feet, 20 to 30 feet for all the cross bracing and stuff. And then all the nose ribs and tail ribs are gonna need 8, 16, 3, 30, 37, so there's 1, 8, 16, 32, and then 2 sheets of 1/4 of 48 for the nose ribs and the tail ribs. So really, might as well say 3 or 4 sheets for that. I'll say 4. That gives you extra. They're gonna need 1 more sheet for the spars. That one can be 6 inches. The 16th inch stuff, you're gonna need, let's say 6 sheets of that. Also 6 inches wide. Actually, probably do 3 sheets since it'll be 6 inches. 3 32nd balsa wood. We're gonna need probably 2 or 3. I always like to do at least a 6-inch sheet, and then 1/8 inch for tail ribs and stuff. You can get away with probably 2 sheets of that. So I'll post this stuff up on RC Scale Builder since it's a pretty quick and dirty estimate. Copies of the plans once I get the horizontal stab stuff. Well, once we all decide what we want to do about horizontal stabs, whether we want to do foam core or what, I'll decide. If we decide we want to do foam core, we'll do that. If not, I'll draw up the. I'll get the ribs from Fuselage and all that stuff and put those onto a separate sheet as well. But so far, this is basically the V-173 plans and what all's involved in building this thing. Should be a, well, once you get the wing groups built, it should be a pretty quick and easy build, considering there's not a whole lot of stuff to do to it. It's just building ribs are going to take forever. So, all right, y'all have a good one. I'm going to put this thing up on the YouTube so you all can see.